All right, let's go through the unit review. Pretty sure I already put a key in Google Classroom, but all right. So whenever we're describing distributions, we have to use CUS and remember to BS. As a reminder, we've got center, unusuals, shape, and spread. The BS stands for be specific. On this set of distributions, we can't see, we're not going to be able to get all of those things because we don't have numbers attached, but we can still get a lot of information. So I'm going to write center, unusual, shape, spread. I'll go through it. In this distribution, the center would be about here because we have a pretty symmetric unimodal distribution. So I'm just going to say, okay, center's about there. There don't appear to be any unusuals. I don't see any gaps and I don't see any spots of potential outliers. So I'm going to say none. For the shape, kind of like I already said, we've got unimodal. So how many bumps? And it's relatively symmetric. And so I'm just going to say symmetric. And in terms of the spread, without the numbers, we can't really get an IQR or a standard deviation, but based on this shape, I'm going to say that the standard deviation is a reasonable measure of spread. And with that in mind, we'd use the mean of this distribution for our center. Median and IQR would also work fine, but because it's symmetric and unimodal, mean and standard deviation are going to give us reasonable pictures of our data. So same thing here, center, unusual, shape, spread. I would say the center is going to be like around here somewhere. And unusuals, again, no gaps or outliers over here. It's pretty continuous. Shape is, again, unimodal. And this is definitely skewed right. Remember, the skew tells you where the tail is. So we've got a lot of empty space to the right, so it's skewed right. And then for spread, because it's not symmetric, this is where IQR is likely going to give us a better picture of what the spread is. And in that case, we'd want to use median for the same reason. Remember, median and IQR, those are going to be resistant to extreme values. Again, we've got center right here in the middle. Unusuals don't seem to be. This shape is bimodal, right? Like a bicycle, there's two bumps. And it's still relatively symmetric. And then for spread, I think you could really use either one here. IQR might be a little better because it's not, it's not unimodal, and so probably median here, but really I think you can make the case either way. A couple more of these. So this one, it's kind of like the reverse. We'll have our center, somewhere in there because it's being pulled on by those low outlier or those lower values, not necessarily outliers. Unusuals, again, no. Shape, this one is unimodal and skewed left. And spread, I would say IQR on this one because of the big skew, which means we'd use median for our center. And last but not least, center is probably going to be around here, right? We have most of our data, but then this is going to be pulling on it some. Unusuals, yes, there appears to be a gap and potential outliers. There's a little cluster over here, so there might be enough data over there that those wouldn't end up being outliers, but it would really depend on the data set. The shape, I would still call this unimodal because there seems to be one real peak here. This isn't creating a new peak over here. It's just kind of a group of values over there. So I'm going to say unimodal, and this is still skewed right. And then the spread, I would probably use IQR, and I'm probably going to use median for my center again. Okay, so every single time you're describing a distribution, write down CUS and remember to be as specific as possible. Cool. Next up, for the linear regression equation, the predicted y value is equal to 3.5 minus 0.017x. Find the residual for the point 3, 4. Okay, residual is always the actual value minus the predicted value. So we're going to end up with 4 minus the predicted value. And to find that, we're going to plug in 3 as our input. Because basically what happened is, in reality, 3 was plugged in, 4 came out. With our prediction model, we're going to see what comes out when we plug in 3. So y hat is equal to 3.5 minus 0.017x. And instead of x, excuse me, I'm going to write 3. Popping that in a calculator, I do 3.5 minus 0.017. Be very careful about those zeros. It's really common to miss this 0 to the right of the decimal. And we get that y hat is equal to 3.449. So that's what we're going to subtract from 4 for our residual. And so 4 minus that gives us 0.551, and that's it. So again, residual is always actual minus predicted, and that's generally true in stats. It's going to be the actual value minus either the predicted, the mean, the expected. That's the general order of things. All right, number 3. 2 variables that are actually not related to each other at all, may nonetheless have a very high correlation because they were both result from some other possibly hidden factor. This is an example of, this is basically the definition of a lurking variable. Extrapolation is not our answer because that is when you have a regression model and you're attempting to use it to predict for an input value outside of the input values that were used to create the model. So thinking back on that one FRQ with the train cars, it would be an extrapolation to use the model for 65 train cars because the data only went to 50. Not a huge one, but that's that. Regression is just that process of fitting a line or curve to the data you have. In outlier, that has that specific definition, either more than 2 standard deviations away from the mean or 1.5 times the IQR above the third quartile, 1.5 times the IQR below the first quartile. And then leverage, again, this is more about regression. High leverage point is a point that's really far out that's affecting the line of best fit. Okay, so just some definitions. 4, you want to take a simple random sample. Remember, that's the only thing that goes by SRS, even though a lot of them have the initials SRS, of 100 of the 700 students who attend Petaluma Junior High. You label the students 1 to 700 in alphabetical order. And in the table of random digits, you read the entries. So that's just pulled from a random digit table. It's just the first couple of blocks. So what are the labels of the first 3 students? Because these go through 3 digits, I'm going to first break this into 3-digit chunks just to set myself up. I'm probably not going to use all of those, but now I can see where the stop points are. So my first number is 655. That's totally going to work because it is in that range of 1 to 700, and we haven't seen it before. Vic's next number of 716, that's not going to work That is outside 700. It is more, it is beyond the digits we used as our labels. 678, totally fine. It is below our 700 and we haven't used it before. But then right here, we have another 678. We're not going to pull the same person twice. So we cross that person out. Last but not least, we have 548. Again, in that range of 1 to 700. Haven't used it before. So here is student 1, student 2, student 3. Good. Next up. Sugar Bomb cereal is including one of 5 Sherlock Holmes action figures in each box during a promotion. Claire plans to purchase boxes until she has all 5 action figures. How many boxes should she expect to buy if each figure is equally likely to be in any box? So this is how many boxes until she has all 5. So the first box she gets, she doesn't have any action figure, so that'll work. But then the next box she gets still has an equal chance of any of the 5 figures. So the expected number of boxes is going to be more than just 5 because she might get the same figurine 3 times in a row. So what I'm going to do is label figurines A, B, C, D, and E. And I'm using letters here because these are numbers, and then I can keep track of letters versus numbers more easily. You could totally call these figures 1, 2, 3, 4, and 5. And because there are 10 digits from 0 through 9, I'm going to use 0 and 1 for A, 2 and 3 for B, 4 and 5 for C, 6 and 7 for D, and 8 and 9 for E, because then each of these digits can represent one box. If I did, let's say 1 to 5, what's going to happen is anything that's not 1 through 5, I just have to get rid of. It's not going to be part of my trial, so I'm going to have a lot of waste here. It would work. I think there are enough digits in here for that to work. I don't think there would be enough digits for you to do 1 through 10, right? If you wanted to give each of these 1 through 10, because then you'd need 2 digits each time. And I think you'd run out because so many of them are beyond 10. So you have to kind of think about what's the smallest number of digits that will work. That's going to be your most efficient process. And then the process is going to be record how many digits / boxes, right? Because each digit now is going to represent one box of cereal until all 5 figurines are collected, and then repeat that, hopefully with a computer a couple hundred times. So show our 3 trials by clearly labeling. Cool. So first digit here is 7. That's going to be figurine D. Next is a 3, which is figurine B. Next is a 1, which is A. An 8, which is E. And a 4, which is C. So we had a kind of lucky experience there in that trial 1. It only took 5 boxes to get all 5 figures. Just happened to work out. Next, we'll do it again for trial 2. And let's see. So 9, that's an E. 5, that's a C. We already have E. So this 9 would also be an E. We already have that action figure. So I'm going to cross this out. You could put an E below it. I think it's easier to only write the letters once so you can keep track of what you're still missing. That's just a personal thing. Here's our A. Here is a D. But then we've already got an A, we've already got a C, we've already got an A, we've already got a D, we've already got an E, we've already got a C, We've already got an A. This is the first one. That's our B. And that was the one we were missing. Now we have A, B, C, D, and E. So trial 2 took 5, 10, 15 boxes until we had until we had one of every action figure. And then trial 3, same thing, one more time. 8 is E, 3 is B. That 3 we already have. 7 is D, 4 is C, 5 is, we already have a C, we already have a B, we already have a B, we already have an E, we already have a D, and here is our first A, and that was the last letter we were looking for. So trial 3 took 5, 10, 11 boxes. All right. Onwards. So when we have transformed regression equations, it's really just algebra. We're just solving for the cost. And so we have to be careful about undoing that it's the square root of cost that this equation goes to. So we're predicting the cost of a TV with a 1500 square inch screen. So we'll just pop 1500 in for the size. We'll get square root of the predicted cost is 2.35 plus 0.025 times, and instead of the word size, I'll write 1500. Putting that in a calculator, 2.35 plus 0.025 times 1500. And that gives us square root of the cost. The predicted cost is $39.85. Now, we're talking about the cost of a TV, so use some context. A lot of you in class square rooted both sides and got a really small number, something between 6 and 7, and thought, wait, there's something fishy about that. That's good, using the context to help you check yourself. To undo a square root, we're going to square both sides. And we'll get a much more reasonable number than 6 for the predicted cost, which is $1,588.02. It's money, makes sense to go to the cent. Okay. Again, same deal. We want the number of bacteria after 23 minutes. So minutes is our time. We're going to replace the time with 23. And this time we have a logarithm. So the log of the predicted number of bacteria is 1.56 plus 0.045 times 23. And so 1.56 plus 0.045 times 23. So we get that the log of the predicted number of bacteria is 2.595. The inverse of log is raising both sides, or raising this to the 10th power. Remember, the base of log is 10 unless otherwise specified. So we're going to say 10 to this power gives us the predicted number of bacteria. If you look on your calculator, you'll notice that the log button right next to the 7, if you do second and that, it's 10 to the. So if you forget what the inverse of log is, you can actually use the button on your calculator to remind you. So 10 to the 2.595, and the predicted number of bacteria ends up being 393.55. Good. Next, match the following descriptions with the most likely correlation coefficient. So we've got one pretty strong negative, one moderately strong-ish positive, and this is very, very close to 0. That's very weak. So the number of hours you study and your exam score. This is a situation where as one goes up, I'd expect the other to go up. So we're going to look for a positive correlation coefficient. And there's probably a decent relationship between those things. So of these two positives, I think it's going to be this 0.46, because this is almost no relation. And when we look at the second one, the number of siblings you have in your GPA, like, would it make it go down? Would it make it go up? Is there any relationship here? I would say that's pretty weak. There's so many things that could be affecting your GPA beyond siblings. And, there's some sort of studies, but that's a really weak correlation, probably no real association. And then the number of hours you use a pencil and its length. So as the number of hours goes up, if we're thinking about a non-mechanical pencil, the length would be decreasing. So this, we're looking for a negative correlation coefficient, a negative R. And this is our only negative. It's very close to -1. So it's actually a pretty strong correlation, which makes sense. Not a whole lot else is going to affect the length of the pencil that you're using, besides using it. So this one's going to be A. Good. Number 8, what does random selection mean and what are the benefits? So what it means is each outcome, each subject or participant has an equal likelihood of being selected. And the benefit, the real benefit, is that randomization reduces the effect of bias. So thinking back to that random rectangles activity we did, the best average we got as a class, the closest average to the true average area of those rectangles, was found when we all selected the rectangles randomly, not when you chose the representative ones, not when you, just made a guess after a very quick look. So randomization, especially in the long run, really irons out a lot of the bias. Okay. Up next, the PHS admin team wants feedback on the new Bell schedule. Name the sampling strategy for each of the following situations. So first, there are 4 years of students, freshmen, sophomores, juniors, and seniors. Randomly select 50 students from each year. So from each year, and we're getting the same amount of students from each year. This is a stratified random sample, and the strata are the classes. The strata don't have to be equally sized, especially if the sample from each strata doesn't have to be equally sized if they're not equally represented, but in school they are generally. Next up, randomly select 10 classes and survey every student in each of those classes. So this is a cluster sample because we are surveying all of some of the groups. So we would randomly select 10 classes, again, that randomization to reduce bias, and then surveying every student versus taking some of all the groups. Next up, randomly select 200 student ID numbers and survey the students who correspond to those numbers. That is our simple random sample. There's no design other than we have student ID numbers. Let's pull a random 200 of them and call it a day. And this, again, is the only one that we'd abbreviate as SRS. Randomly select a number between 1 and 65 using the list of student ID numbers. Start at the randomly selected number and then survey every 65th student from the list after that. This is our systematic random sample. All right. So those are all basically just vocab definitions you need to be able to identify what type of sample you're looking at. This last one, we didn't really go into it too much in class because it is not a valid sampling strategy. It is something that sometimes is suggested, but it doesn't produce good results. So survey the students who are attending classes in the A wing because it's close to the office. This is what we'd call a convenient sample, right? If the principal and assistant principals wanted to quickly check in with students, the classrooms in the A wing are the closest. That doesn't mean they are representative of everyone in the school. You can think of a lot of different reasons why the A wing might not be representative at different times of day. So this is not a valid or good strategy. Okay, onward. More dogs are being diagnosed with thyroid problems than have been diagnosed in the past. A researcher identified 50 puppies without thyroid problems and kept records of their diets for several years to see if any developed thyroid problems. What kind of study is this? First question is experiment versus observational study. Because there is no manipulation, there is no applied treatment, this is an observational study. And because the researcher identified 50 puppies and then kept records of their diets for several years, so he started when they were puppies and then kept track of them, this is also a prospective study. He wanted to keep track of something going forward rather than a retrospective study would be he would gather information about their diets looking back after they had developed thyroid problems or hadn't. This is prospective because he's following them. All right. Number 11, Jacob wants to know how athletes at PHS feel about the decorations and signs put up by ASB for Egg Bowl Spirit Week. What is his population of interest? Okay. He wants to know how athletes at PHS feel. So his population of interest is athletes at PHS. So if Jacob does a sample, he's going to want to take a sample of athletes at PHS. Cool. Next up, I'm actually going to pause there and then I'll do a part 2 video.